Hello students, today we will see how we can derive a formula using dimensions. It seems as though dimensions is like a James Bond. He can drive a car, he can ride a helicopter, he can ride an aeroplane, and dimensions seem to do many things, even derive a formula. Let us see. So here we have a pendulum whose length is L. From the top of the string to the middle of the bob, that is the length L. It has a mass m and gravity is acting on it, and the gravity is g. So intuitively, common sense says somehow the time period. What is the time period? The time when we pull the pendulum to one side, bob to one side, and let it go, the time it takes for the bob to start from this end to go that end and then come back, that is one time period. So intuitively, or an intelligent guess will lead us to somehow the time period of the pendulum is related to the length of the string, mass of the bob, and the gravity. So somehow this is dependent on these things, these quantities. So let us say the time period t is equal to some constant k into L to the power of a, m to the power of b, and g to the power of c. Some constant, some numbers where this is dependent on this. Now let us see how we can find out what a, b, and c are using dimensions. So what are the dimensions of L? Length. Dimensions of mass, m. Dimensions of g, L t power minus 2. So if we write these here, so t becomes t is equal to k into L power a. So here we have the dimension L power a, m power b. So m power b and g power c. So L t power minus 2 to the power of c. So this becomes t is equal to k L power a, m power b, L power c, and t power minus 2c. So this is equal to t is equal to k. Let us gather all the same dimensions together. So this is L power a into L power c, L power a plus c, m power b, t power minus 2c. Now on the left side, the only dimension we have is t. So what happened to the, so we can write this as m power 0, that is 1, into L power 0, that is again 1, into t power 1 is k L a plus c, m b, t power minus 2c. Now in earlier lectures we had seen that there are no dimensions for the numbers, constants, so we are going to take it out. So if you look at this and we equate the powers, because we have dimension m, l, t, m, l, t. So a plus c is 0, these two, and b is equal to 0, these two, and minus 2c is equal to 1 for the time period. So from this we have c is equal to minus 1 by 2 from this. Now if we put this value in this equation, we have a plus c is equal to 0, a plus c or plus c minus 1 by 2 is equal to 0, or a minus 1 by 2 equal to 0, and a equal to 1 by 2. So what values we have here? A is equal to 1 by 2, B is equal to 0, and C is equal to minus 1 by 2. So these are the values we found out using dimensional analysis. All right, now let's substitute these in our original formula. So what do we have now? T is equal to K into L power A, L power 1 by 2, M power B, M power 0, G power C, G power minus 1 by 2. What is L to the power of 1 by 2? L 1 by 2 is nothing but root of L, and G power minus 1 by 2 is 1 by root G. So we write it here. T is equal to K root L, M power 0 is 1 by root G, or T is equal to K into root of L by G. So the time period of a pendulum is K root L by G. Now we don't know K, but using experiments people have found out it is 2 pi. So T is equal to 2 pi root L by G. So what did we do? We said we want to find out the time period of a pendulum, and we know the time period, we intuitively guess that the time period is dependent upon the length of the pendulum, mass of the pendulum, mass of the bob, and also the gravity of earth. So we said T is dependent on L, M, G. Let us assume T is equal to some constant K into L raised to the power of A, M raised to the power of B, and G raised to the power of C. So, and using dimensions, we found out what are the dimensions of each quantity, and then we found out that the time period is K, L power A, M power B, L T power minus 2 to the power of C. And when we equate, these are the values we have got, and from that we derive that the time period of pendulum is 2 pi root L by G. Now does this mean we can derive all the formula like this using dimensions? No, there are limitations. See here, luckily this was a product equation. All the dependent quantities L, M and G, they are product, so we were able to find out. Earlier we saw some equation, S is equal to ut plus half at square. This is the distance travelled. Now if you look, there are two products being summed up. So this kind of formula we cannot derive using dimensions. Also the constant K, we don't know what the constant K is from dimensions. Also here we had three unknowns. We have introduced A, B and C. We don't know what these are, and we tried to find out. But because we had three equations, 1, 2 and 3, we have three equations and three unknowns. That's the reason why we could calculate what they are, otherwise no. So these are the limitations of this deriving a formula from dimension. And also the time period for this pendulum is valid only if the angle is small. We have to make a small angle, only then this formula holds good. T is equal to 2 pi root L by G. So we need to know what are the assumptions and what are the limitations of the formulae that we are using. All right, we'll see you in the next class.